now that we've learned about quadratic functions and all the different ways to graph quadratic functions, now we're going to talk about quadratic equations. So we're going to take a quadratic function and we're going to put it in the form of an equation. Now, basically what we're going to be doing here is we're going to be looking to solve the quadratic equations, which means we're looking for all the values of x that make the quadratic equation a true statement. Now, there are many ways that we can do this, and the very first way that we're going to talk about is through factoring. And up to this point, you should have learned multiple ways to factor. So I just want to quickly review the methods that you learned how to factor. So the first thing we basically did is we learned how to factor out a common monomial, which we call a greatest common factor. That's GCF. And then we also learned some special cases. So we've learned special cases such as perfect square trinomials and difference of squares. And then we've learned how to do trinomials with an a value equal to 1. We've also learned how to do trinomials with an a value greater than 1. And if you remember, we use a process called grouping to do that factoring. Now, any one of these types of factoring methods can be applied to solving the quadratic equation through factoring, assuming that it can be factored. So the quadratic form written in standard form equaling to 0 is how we're going to use this to solve the quadratic equation. Now, if you notice, the 0 is highlighted is representing the y value in this case, and so we want all of the x values when y equals to 0, and those are just the x-intercepts. So if y equals to 0, we're talking about our x-intercepts, and so we will call those the zeros of the quadratic function. And so that's some terminology that you should be familiar with. Now, if we make it equal to 0, we have a property called the zero product property, which basically tells us that if two factors are multiplied together and they equal to 0, then we can simply separate the factors and make them both equal to 0. It's extremely important that they equal to 0 and not some other number. So let's take a quick look at some examples here. Alright, example 1, part A. You can see we have x squared plus 3x minus 18 equals to 0. In this case, this is just a simple factoring problem. And once it's factored into x plus 6 times x minus 3, you can see we have two factors equal to 0, so we can break those apart. And then once they're broken apart, we have two simple linear equations that we can solve for x. And now x equals to negative 6 or x equals to 3. If you were to plug negative 6 or 3 back into the original equation, you would get a true statement, and that would let us know that our solutions are correct. If you look at part B, the first thing that we have to do here is we have to make it equal to 0. Now, one of the things that you may notice in the second step is they have a common factor. The difference between factoring and solving using factoring is that we can actually divide that common factor out. We do not have to hold on to it like we did whenever we were just factoring. So we can actually eliminate the 2 in this case. And then once we have that eliminated, we can just do the simple factoring, and you can see we're dealing with a perfect square trinomial here, so we only have one solution, or 1, 0. Alright, so those are some good examples of solving quadratics using factoring. What I'm going to ask you to do now is to take a look at sample problem number 1, part A and B, and go ahead and work those on your own, and then come back here and see the solutions when you're finished. Alright, so for the first one, we can go ahead and start right off, and we can factor this. And we have x, and 26 will break up into 13 and 2. Now, since we have equal to 0, we need to make sure we carry that equal to 0. The equal sign should stay a part of our entire problem. Now I'm going to break these up using the zero product property. It would be appropriate to say the word or, because it's going to be either answer. And our two solutions are x equals negative 13 and x equals to negative 2. Now, if we were graphing this, you could say that these were the zeros of the function, and they would just simply represent the points where the graph would cross the x-axis, or give us the x-intercepts. But right now all we're looking for is the x value. Okay, if we look at the next one, we need to start off by getting everything on the same side of the equation. So I'm going to add 3x, and I'm going to add 5 to both sides. Then I'm going to simply divide out the common 4 here. If I divide out 4 from everything, what I'm left with is x squared plus 4x plus 4 equals to 0. Now, I could have factored out the common 4, but it wouldn't have helped me get any other solutions. It just would have been a random 4 sitting out to the side. So you can factor it out, or you can divide it out when solving. And so I'm left with x squared plus 4x plus 4, which is a perfect squared trinomial, x plus 2 and x plus 2. And then you can see here that these result in the exact same answer of x equals -2. And so we only have one solution, or one x-intercept. Okay, and those are your examples of solving quadratic equations through factoring. In the next section, we'll learn another method of solving quadratic equations.